Okay, everyone. Hello. Good morning. It's a nice cold morning in Sydney, as a few of you in the chat have identified. So hopefully you can, chuck on a blanket, chuck on the heater, and enjoy the good vibes for the 1511 lecture. Let's get straight into it. First of all, hello, everyone. As a few of you have just mentioned, yesterday was a public holiday. So a few of you that had tute labs scheduled for yesterday, no, you don't have to just miss out completely on your classes this week. You can attend any online tutorial scheduled. So you can just go to the course website, go to the timetable, find one of the online tute labs that's scheduled this week and just use the link to attend it. So they're running on all 4 of the other days, I suppose, up until this Friday. So you should be able to find one that fits into your schedule, and then you can just attend that. So that's only for those of you who missed yesterday's tute lab. And then potentially one of our tutors will have recorded their online tutorial this week. So if you really can't make one of those online tutorials, you could just watch the video back. So that's only for those of you who missed a class yesterday because of the public holiday. Otherwise, congratulations to those of you who follow Australian football, soccer. I only read a headline, but it sounds like a good victory for Australia. So congrats if that's something that interests you. Morning, Bonrick. Okay. So I think we're just going to get straight into it. We've got 2 topics today, one smaller than the other. The first is a discussion on code style or code quality, which is a really, really important topic. And then the topic that I'm really excited for, and one that's going to make your lives a lot easier and help you write much better code, is functions. So I know a few of you are ready and excited to discuss functions. So code style, we're not going to spend too long talking about it because it is a bit early in the course. We'll be talking about code style a lot throughout the course, I think. But we'll introduce the topic a bit more formally this morning, and then we'll get straight into functions. Sound good to everyone? I don't think they are in assignment 0, Nikhil. I don't think there are functions in assignment 0, but maybe in the last stage, I can't quite remember now. Okay. How is this looking? Yep, that's perfect. Okay, good. Okay. All right, lecture 5 goes quick. So as a quick recap, last week we talked about a lot of things: if statements, while loops, some extra stuff on scanf, and we also looked at custom data types, so structs and enumerations. So really, the pace is quite high in COMP1511, and it's going to continue to be high in 1511. I think there are functions in assignment 1, not assignment 0, Bonrick. Okay. So today, as I just mentioned, we're going to be talking about code style. Code style is actually something that I'm really, really passionate about. A few of you probably know my background is software engineering, even though I studied computer science, but like a lot of you, when I went out into industry, I worked as a software engineer, and then I worked as a research engineer. But basically, I spent a few years. I think the big difference between software engineering and computer science is writing production code, and systems that are resilient and are long living. And when you're doing that, one of the most important things, we need to solve the problems, use the right algorithms to solve the problems. But we also need to be really conscious of our code style and our code quality. We need to be consistent, make good decisions, so that if an engineer in a year, 5 years, 10 years picks up a code base, the code you've written really describes quite elegantly what it is it's trying to communicate. And so some of the projects I've worked on have been code bases that have existed for almost a decade. And so if you're looking back at code that someone wrote, might be yourself or someone else wrote, 10 years ago, things change and you can't go speak to that person. But if that person wrote their code with a strong code quality, It's going to be clear what they were trying to do, what problems they were trying to solve, and you're going to be really happy. So we're going to start introducing this idea of what does it mean to write high quality code and correctly style our code. So like I mentioned, it's something I'm really interested in. Of course, the lecture code is all available. So you can head on to that link. I'll give you a second to open it. And maybe someone can put it in the chat, please, Tammy or Noah. As always, we have Tammy and Noah here helping out moderating the chat this morning. So thank you to those two. Kadavaki says, sorry, where can we find the information about the help sessions? We're in the middle of scheduling them right now. We might be able to get some in for the end of this week, but definitely for next week, and we'll make an announcement when that's all ready. Okay, thank you, Tammy. All right, so what is style? What is code quality? Why do we care about it? If you've programmed before, you've definitely or probably felt this. You look back at code that you wrote even a few weeks ago, a month ago, and you're like, who the hell wrote this? This makes no sense. What fool programmer wrote this file? And then you look at the top and it's like written by you, and you're like, oh, I wrote this. Or you're working on a project, you look at the Git history, and you're like, again, what fool wrote this program? And then it's you a year ago. And you're like, ooh. So why does this happen? Part of it is that hopefully we're always improving as an engineer, as a developer. And so our style naturally changes, and we pick up, sometimes very slowly, but we pick up better practices over time. And when we look back at old code, when we weren't utilizing those practices, we think, oh, that looks really ugly. And actually, that's a really good thing. If this is happening to you, and it's going to happen to you a lot in COMP1511, you will look back at early code and you'll read it. I promise in a few weeks, maybe already it's happened, and you'll go back and you'll read it and you'll think, I had no idea what I was doing. This is awful. That's a really good thing. If this is happening, that's awesome, because it means you're growing as a developer. So to sort of sum up what we're talking about here, it's important to note that when we write code, when we write C, it's a language written and defined by humans and for humans that happens to be syntactically structured enough that the computer can compile it to a format that it can understand. So what we're doing when we're programming really is we're operating in this middle ground between something structured enough that computers can understand the instructions, but human and communicative enough that other humans and that we can understand and abstract on the instructions. Does that make sense? So we have a pretty tough gig because we're operating in this middle ground between the machine and the human. And anytime humans are involved in any activity, that's difficult because it's hard to communicate. So we need to understand that the code we write, yes, it needs to work. It needs to work for the computer. It needs to solve the problems efficiently. But, the other important side to this is that it needs to be, ingestible by other humans who read your code now, tomorrow, in a week, in a month, in a year, or in a decade even. So we want to make it easier to read, easier to understand. A term I like to think about is glanceable. If you write code, it should be glanceable to look at and think, I completely understand what, Tammy was writing here or Nikhil was writing here, for example. We want it to be neat. What does that mean? It's a bit subjective. If we have high quality code, what does that mean for engineering in general? Well, it means it's easier to build on that code, understand that code, build new features, fix bugs, etc. So coding, we should always aim to have a strong sense of style when we work because it is worth it. And now, again, a lot of this stuff is subjective. It's arguable. There's no clear solution. Different companies, institutions, even universities or different courses will have different ideas of what correct style is. So part of it is doing sort of what you're told. If you are operating 1511, we have a style guide, and part of your job in 1511 is to adhere to that style guide. When you go out into industry, if you're writing code in industry, they will have a style guide, probably stricter than ours. You have to adhere to that, and there's tools to help you do that. But then there's this, so there's like that's like your general code style, you know, how do you name identifiers and things like that. But there's also, you know, not everything can fall into a style guide. So there's decisions that we make every day as an engineer. And what makes a really good engineer is being able to write really clear code. Okay. So exactly what do we mean? We're talking about indentation, bracketing. So, you know, where you put the brace, how far you indent the code. A big one is the names of identifiers. So your variable names, your function names. You know, any time that you can pick a name for an identifier, that name is really important because it should represent exactly what it is that you're dealing with. How we structure our code, maybe overly nesting is a bad sign. Too many nested while loops is also a really bad sign because that's increasing the complexity and decreasing the performance of our code. Comments is another big one. And again, another very subjective one. So I actually think personally, and this may actually disagree with even the 1511 style guide, but we should aim to need as few comments as possible when we write code. So what do I mean by that? What I mean by that is our code should be so simple to read that a comment describing what it does would be redundant. That's my personal view. And I think it's difficult because when we're teaching programming for the first time, we say, yeah, you should document your code and make it clear what it's doing. But if you write code that is dead simple, you don't actually need to do that. You don't need to describe, you know, if you assign a variable the value of 10, you don't need to write a comment for that. It's obvious. And consistency is the big one. Really, it doesn't matter what style you pick, but you should definitely, that's like the easiest rule. You should always be consistent. If you're inconsistent, that's a bad sign. Okay. So when I read your code, I should be able to understand what that code does just from your structure and variable names, and I completely agree. I don't know where that quote came from exactly, but completely agreed. Okay. Let me read some chat questions. Who is grading the assignment 0 so I can adjust the number of comments? Assignment 0 I think is auto-graded, so you're okay in this case. Yeah, over-documentation is not a good thing, but appropriately documenting is correct. Says Joe. Nicole says, one-line summaries of what we've been doing at the top of the program part of the style guide. So yeah, that's an example. That's different. So when we have at the top of the file, and I'll jump into some examples with this, when we write some comments at the top of the file to describe what the program is doing, that's a bit different. That's not what I'm talking about with the inline comments. So you should continue to do that. And really let me see here, the 1511 style guide 22T2, I'm just Googling it. Let's go hit the course page. So the cool thing is that regardless of what's going on, you can read our really detailed style guide. Hopefully you've all read this already. And we've listed what we expect. Tammy's just reminded me that actually Assignment 0 does have some manual marking from the tutors. But the good thing is that all of the marking will be sort of making sure that you're adhering to the style guide that I've listed here. So maybe someone could put this in the chat as well, a link to this. And you can read through in more detail exactly what 1511 expects. So you could look at, for example, comments. You know, we haven't talked about functions yet, and you can even get some examples here of what's going on. But my point is a lot of this is subjective. So some of you have already programmed before and might actually disagree with some of the choices we've made in our style guide. That's completely okay. It's not necessarily saying that we're right and you're wrong, but what's important is that you adhere to the style guide for your, I guess your employer, in this case, your institution or your course. So definitely bookmark this website for 1511. Okay. Jacob, we haven't spoken about functions or function prototypes yet, so why don't we pause on that and remind me and ask me again at the end of when we start talking about functions. Deal? Okay. All right, so if a lot of this, like I've said, is subjective, why don't we look at some practical examples of some bad style and point out exactly what is a good example and a bad example. So I've got some code here that I'm just going to copy. I'm going to open gedit, paste this in. Sasha wrote this. Thank you, Sasha. We'll say 22T1 this was written. Actually, this is not functions, so let me just go file, save as, week 3, bad, style.c, save. Let me remember to, actually, okay, that should be now available to you. I can put this here. Whoops. Okay, let me just get our nice... Okay, lots of questions about style. I'll get to them in a second. Let me just get set up. All right. Okay. Prison Mike, hilarious username, says, how do we reduce nesting if we have overly nested our code? There's actually a few techniques we can utilize to reduce nesting, especially with nested if statements and things like that. But it's a bit hard to explain without an example. So you can always post an example to the forum or something and I can jump on and have a look. Or if I get to it, we can describe. How do we find the code from the lectures? Could someone please... Yep, Tammy's already got it. Thank you so much, Tammy. So Dwayne says, would an example of something you wouldn't need to comment about in your assignment be if statements, like the logic inside, because most of the time it's pretty obvious. Yeah, and we can, not always, Dwayne, but sometimes. And we'll talk about it with some practical examples here. Yeah, okay. Okay, all right, so here's some code that Sasha wrote last term. Let me make this bigger. There's no need to cut it off there. And again, of course, let me know if it's not readable. So why don't we spend a few seconds or a few minutes just running through the program and trying to understand what it's doing, because it's the first time we're looking at it. All right, so like we said, Sasha's introduced this program. We do want to do this. So Sasha's saying this is there's some examples of bad style here. And I'm actually not sure if she's already fixed some of it up, because it's not the worst program I've ever seen. It's possible, but yeah, late night coding, someone writes up some program, and what do we do to fix it? Okay, so we're including standard IO, that's completely fine. We have a hash define of this budget of 10. Already on line 12, I would be thinking, if I was reading this, this intentionally poorly written file. So, or budget of what? What budget? And what format is the budget? Is it dollars? Is it thousands of dollars? What currency is it exactly, AR? Yeah, so we could already start to see here that we could be more expressive with our variable names here. So, and the budget of what, of the business of the year, of the financial, like what's the budget? Okay, then we have this struct called ice cream. So the ice cream's got a price, it looks like an int scoop. Here I would also be thinking, well, is it the number of scoops? Is it the size of the scoop? Right, so just already in this program is not too bad. I think it's actually already been cleaned up a little bit, but there's always opportunities to really make it dead simple. If there's any ambiguity, it's an opportunity for someone to scan through the code and then make a false assumption that then leads to a bug, for example. And then the car of the flavor, that's probably okay. All right, then we have our int main here. Cool, we have our bracket. Can anyone spot an inconsistency between line 22 and line 15? It's only a minor one. Yeah, exactly right, exactly right. So here there's a space, here there's no space. You might be saying, look, Jake, that is the most minor thing I've ever seen. Why do we care? It's all about consistency. So we do care. Okay. Then we're defining or declaring this struct, the ice cream struct. So this ice cream struct that we defined up here. Yeah, the extra line as well. That's a good point. And we're calling it bill. That also is, to me, a bit confusing. This struct is called ice cream. It's defining the name of it indicates that it's defining information about ice cream. But then we're calling the variable bill. So is it a bill? Like, to me, a bill is different from an ice cream. Or like, should this be called an ice cream bill struct, for example? Or is it your neighbor bill? Yeah, exactly. So someone's just asked what's going on in line 12. This is a hash define, so it's defining a global constant. So anywhere the word budget appears, which, for example, here, you can imagine that this just gets replaced with whatever that value is. So in this case, 10. So that's just a global constant. Okay, we do need this semicolon on line 19 though, Noah. Yeah, so exactly, Nicholas. Maybe we could call this, ice cream bill, something like that. I'm not going to actually go through and rename it. Okay. Int total equals 0. That looks okay. Again, total what? Maybe the total price, for example. We could be more clear here. Then we're assigning bill.price at $1.25 or 1.25. This is actually an example where a comment actually would be good. So, why is it 1.25? Where did that 1.25 come from? Does anyone actually know, you might not, that's okay, what we would call this? Other than I'm not saying like the data type of it, a double or a float or anything like that. What do we actually call this? Oh, amazing number. Straight on the money. Oh, I've already let the cat out of the bag. So, yeah, it's a magic number. So what does magic number mean? Why do we call this a magic number? Anytime you see something like this, warning signs should be ringing. An amazing number has got it. It's a number that nobody knows why it's there. What 1.25? I have no idea. I literally don't understand. I don't know why it's here. There's probably a good reason. Maybe if we read the rest of the function or the program, we'll figure it out. But there's no. It's a magic number because it's just been plucked out of nowhere. What probably should happen here, if we do actually want to do this, we should have something up here like a hash define, base price. Let's assume that's even what it is, 1.25. So that we can actually assign, stop calling me amazing number, stop it. Okay, if you let me know what to call you, I'll call you that instead. But we can assign it, for example, base price here, and you can see that this line now is much more clear as to what, we don't know what this 1.25 is my point. So therefore we call it a magic number. Okay, there's some questions about, it has no meaning, it's arbitrary. Exactly right, yep. Some questions about the hash defines again. In C, this is just how we define global constants, or I guess one of the ways we are defining global constants. They work differently from, so it's not a variable is the reason why we don't have this assignment statement. I don't really want to go too much into the details of how this works, but basically this occurs, anything with a hash, so the hash include, the hash define, usually occurs in the pre-processing stage. What you can think about, what's happening is that when the compiler sees this, it like literally does a control C for budget, and it goes, okay, I found it here, and then replaces it with 10, and then it compiles the program. So it actually happens before the program's compiled. So it's not actually there's no memory used to store the value. That's right, Joe, it can't be changed. Yeah, so if we're using this value in multiple places, if we change it here, it would all just update the next time we compile it. So if you are interested in that stuff, you can Google how hash defines work in C. In more abstract languages, they don't work like this. Usually we just have a constant, which is a piece of memory. But these are very efficient because it doesn't need any memory. Cool. Okay. One of the bugs I always used to accidentally write when I was writing C++ was I'd put a semicolon here, because we usually end our statements with semicolons. But the reason this is a problem is it actually replaces budget with 10 followed by a semicolon, which is not what we want. So these are really sort of dead simple. They're not actually expressions. Okay. Tracer says, if I define budget again on, say, line 13, which value would it use? I think it would use... It's a good question, actually. How do I even Google this? Maybe Tammy or Noah might already just know. Yeah, you might get an error. I'm not actually sure. You'd have to try it. Give it a go. See what happens. I don't know if it would apply the first one and then not be able to apply the second, or just give you a warning when it detects that there's multiple. Okay, someone's just asked why is 1.25 a magic number? Right now, who asked this? Matthew? Again, sorry if I'm mispronouncing these names, but they're not always sort of clear. If you look at line 29 in isolation, right? Can you, by glancing, can you tell me why it's 1.25? You might have looked ahead and you might know, but I would posit that from a glance, the answer is no, and that's why it's a magic number. It's magic because it's been plucked out of nowhere. It's not. This isn't a formal term. It's just it's a well-known term, but it's just a random number. It's just some random number. I don't exactly know why it's there, so I'm calling it a magic number. And they're bad in general. They're bad. Cool. Okay. All right. I mean, are these examples helpful? Do we want to keep going? Are you starting to get the idea? It's not something, code style, code quality is not something I can teach in a, 1 hour, even 2 hour lecture. It's something that you're going to have to be thinking about for the rest of your programming career. It just is. And we'll be talking about it as we go throughout, in future lectures and tutorials and things like that. And as we come across things, I'll try and point out more often what would be a good example or a bad example of code quality here. All right, some questions. Joshua has asked, is it okay to have an if statement but not have an else statement? Completely okay. Sometimes we only want to do something if something is true, but otherwise we don't want to do anything else. Self-improvement. Nicole says, wow. I don't know what that was about, but that's okay. The price of each scoop is $1.25. Sure. So that's right. Okay, so that should definitely be a hash defined, scoop cost 1.25. Do you see what I mean? Now, right? This is dead clear. This is glanceable now. We've improved the code quality. And then we don't need the comment. Do you see what I'm saying? Do you see how if we write better code, we don't need as many comments, generally? All right. Okay. So yeah, write comments where they're needed, but don't over-comment. Name your variables based on what that variable is actually there to do, not on what it should do, not on what you think it does, but what it actually does. Make sure you surround your blocks of code with a curly brace, sure. In 1511, we use 4 spaces for an indentation. That's pretty safe. And there's a few more things here. But again, you can go to the style guide to read more explicitly. I did want to I think, is this the end of... Oh, no, okay, this is the link to the style guide. Like we said, yeah, different organizations work differently. There's no point arguing with your boss. I mean, you could make a valid argument that, hey, we should change this style guide here. But in general, you just have to adopt the style guide of where you're working. Okay. I'm just asking something. I did want to mention, I think, is this the end of... Oh, okay, we have some more cool stuff. We haven't really spoken about nesting so far, but I think it'll come up and I'll talk about it. All right, so some shorthands that may or may not improve our readability. You've probably seen some discussions about this in the lecture chat if you've been paying close attention. Some of these things you could argue maybe could make our code a bit more readable, maybe a bit more concise. So as an example, so far when I've been doing incrementing in the lecture code, I've been saying, well, the count is equal to the count plus 1. There is the shorthand or syntactical sugar for count plus plus, which these two are completely equivalent. We can do the same thing with subtracting one, right, with count minus minus. So, a bit less code, a bit less to ingest, but really this isn't a big deal if you do either one or the other. You can also use a similar shorthand or a syntactical sugar to increment by more than just one. So you can say count plus equals to 5, count minus equals to 5, and even count multiplied equals to 5. So these, you can sort of see what their equivalent is doing. They take the value, they unpack it, multiply it by the right-hand operand, and then return it back to the left. not tactical sugar, syntactical sugar. Okay. Do I recommend using count plus plus rather than count equals count plus 1 in assignment 0? For assignment 0, you could use either. I think divide equals works. You got to tell me how to pronounce your username now. But yeah, divide equals I think also works. In general, I probably would be fine. Plus equals, this is fine. These are also, you could do plus equals to 1 or you could do plus plus. But do I prefer one over the other? Oops. I don't know. It's complicated, I guess. Because sometimes I don't want to complicate this even further, but this is a post increment. There's also these things called pre-increments, and I'm not even going to get into the discussion of them, but you can do plus plus count. And sometimes students get confused between the two, and actually being more expressive is simpler. I have seen as well some style guides that avoid plus plus. I don't think ours do. So in general, I think it depends. I don't really have a strong opinion on it. Yeah, counts is just a variable here. And Andre says, are overly long variable names a bad style? This is actually such a good question. So I would answer that unnecessarily long variable names are bad. But variable names or any identifier name should be expressive of what it's representing. And if that means it needs to be a bit longer, I mean, what's the harm? I think a lot of programmers tend to want to write really, minimal identifier names. And I don't actually know why. Sometimes it's just like, maybe to make it look more confusing and to show off. Maybe it's because they think it's more efficient. I don't exactly know. But so variable names should be, I think, don't stress too much about having them be really short. You don't want them huge. You don't want full sentences. But you don't need to keep them as short as possible either. Maybe some environments, like statistical things, are different. We don't want anything crazy, but don't worry about, I'll have to type more characters if it's that long. Our editors will do a lot of auto-completion for us, so it doesn't really matter. And don't forget, a long variable name, when it gets compiled, it gets discarded anyway, so it's not going to affect the efficiency at all. Okay. Is there more here? Okay, no, I did want to just mention, let me see here. This is probably my favorite book on code, or maybe like my favorite initial discussion on code quality. It's generally, I think, accepted as a really good resource on writing clean code, which is all the things we're talking about today. And it provides some heuristics on what you should and shouldn't do, how long a function should be, how to think about identifiers, and things like that. It's a really short book. It's a really easy book to read. You would all understand it, or most of it already. I'm not saying go buy it, but I think it's a really good resource if you're really interested in this stuff. I get the audiobook for free. That would be weird. Don't get the audiobook. It's a good resource. I like this book. I think I've got it somewhere actually, but anyway. Okay. Yeah, if you... Okay, I'm not going to suggest you do or don't do that, AR. Anyway. Okay. So we have the break now before we talk about functions, I think. Okay, we've got our Kahoot is 3 minutes away from being ready. So do we want to do just some last minute questions on anything so far in the course? And then we'll do the Kahoot, then we'll come back and then we'll talk about functions for the rest of the lecture. Does that sound good to everyone? Awesome, we'll fire away. Okay, James, I don't have anything explicitly to talk about over nesting. I can, you know what? I can probably come up with a really quick example. Let's see how quick I can go here. Int main, we want to put a void here. Okay, let's bring this down here. So let's say we have int, some variable called x, and we'll assign it the value 5. Then we'll have some int y, and we'll assign it the value 10. Let's just do this. Let's say I want to do something if both of these variables are true. This is a bit of a contrived example, but I think it should work. So I could say if x is equal to 5, do something. Now, I want both x and y to be equal to 5 and then y equals to 10. So I could say if, right, y is equal to 10, another pair of braces, and this will only run if both x is 5 and y is 10. Do we all agree with this so far? You don't have to follow along, typing this, I'm just demonstrating. All right, awesome. Do I need both of these? How many levels of indentation do I have? I've got this, I've got the one from main. We can't avoid that, that's completely fine. I've got this one here, which launches this level of indentation. Then I've also got this block here, which launches this level of indentation. I could also just simply do if x is equal to 5 and y is equal to 10, then just do this. And this is exactly the same. So whoops. What a yell. Or I could do this, and I'll leave it up to you to think about which is more expressive, which is clearer. I forgot the return 0, that's fine. We're not too worried about that though. Which is clearer, which is more glanceable? I would definitely say this second example. I read it, is x 5, is y 10? Yep, then they're both running. This is an unnecessary example of indentation. Yeah. You can imagine, if there are more than these two, then it gets more and more complicated. But then also, if you have like a lot of variables that you want to check here, it could also get too long, and then that could get too complicated, and there's ways that we can make that more clear as well. Okay. I will point out though, again, everything we talk about has a caveat in programming. This is why it's difficult. There are cases where you need to do it like this. For example, if there's something you need to do when x is 5 always. Right? This now might be clearer. So it depends. Yeah, it always depends. There are no hard and fast rules. This was just a rough example. There are other ways to cut down on unnecessary nesting. An example is a function as well. You could bring it out into a function or a procedure and deal with it somewhere else. Okay. All right. So thank you. I don't want to share the questions too early. Am I not logged in? Oh, come on. Again, we wrote this really quickly, so please don't at us if there are some issues with it. Okay. I want to put this up. I think I'm learning here. I want to minimize this. This should just be music when I start. All right, we're good to go with the Kahoot, and then we'll get into functions. Joshua, it does make sense. Maybe I'll talk about it after the Kahoot. Oh, you need the link? No, I gotta just do this first. All right, let's do it. Of course, if you want to instead go make a coffee, use the bathroom or whatever, this is the mid-lecture break, which works nicely because then we have a bit more time to talk about functions. Oh, how did you do that? Oh, did I just delete you? I didn't know you could do that. Could you? Sorry. Hopefully you can join again. I didn't know that did that. That was cool though. Hopefully you can come back in. Wrecked. Okay, you're back. Good. Good. Sorry, I'm not going to touch it. It looks like you had that ready though. It's cool. CS Cardle, that's funny. Not Jake's dad. I like it. I like it. All right. 5, 4, 3, 2, 1. Oh, there's people still joining. Kenobi, is anyone watching it? How's that going? All right, I'm going to start it. All right, style. Let's talk about it. Oh, there's no audio? Okay, this is just some instructions. I don't understand this question. Makes sense. That should be better. Okay, gotcha. Okay, thanks, Tammy. It's just an instruction for the next question. Okay, let's go. All right, the actual question. Variable names must start with either a letter or an underscore. Is it a C language rule? Is it a style rule? Or is it not a rule at all? Okay, 36 people are saying it is a C language rule, which is the correct answer. You can't start a variable name with a number, for example. So it's not a style rule. It's a hard rule in the language. And it is definitely a rule. So looks like a good question though. Even spread between the three answers. Very interesting. Joe Biden wake up is on the top of the leaderboard with this one. The music has you stressed. Variable names can contain numbers as long as they aren't the first character. Is it a C language rule? Is it a style rule? Or is it not a rule at all? These are good questions, Tammy. Okay, awesome. A lot of you have identified this is the C language rule. It's definitely not a style rule. It's definitely not a rule. So, yeah, that's right. C language rules are like the compiler or the computer rules, and the rest are just rules that we've made up for ourselves. Like, oh god, why do you have to be on top of the leaderboard with my name? I'm gonna get mutinied again. Okay, variable names must be lowercase with words separated by underscores. Variable names must be lowercase with words separated by underscores. Is it a rule in the C compiler? Is it a style rule or is it not a rule at all? I don't know why everyone's saying no. Okay. So a few of you, this has got a few of you as well. If this were a rule, it would be a style rule, is the reason why the correct answer is style rule. You could have an uppercase variable name, but we reserve those for constants in C usually, but it is possible. So that's the reason why it's a style rule and not a C language rule. Oh, tough round. 9 players lost their streak. Interesting. Someone needs to dethrone Jake Rinzella. Hash defines must be in uppercase. Is this a language rule enforced by the compiler? Is it a style rule that you may or may not adhere to in 1511? Or is it not a rule at all? Okay, very good. Well, yeah, sort of good. 37 of you have identified it's just a style rule. You can make hash defines lowercase in C. However, we don't do that in 1511. Joe's lost his streak, it sounds like. That's no good. Epic Coda coming in. That's quite close. You can do it. What's the fastest I can type? Yeah. Variable names that contain vowels must be avoided. It's a C language rule, a style rule, or not a rule at all. Okay, some of you are trying to throw each other off. Most of you have got this. Yeah, obviously, we would definitely not want to do this. That would be super confusing. So it's definitely not a language rule. It's definitely not a style rule. In fact, it's something you should definitely avoid. Alex Brown's jumping in at 39th. Congratulations. We have dethroned Jake Rinzella. Interesting. Big shake up here. And then underscore Jake Rinzella. Upside down is climbing, it looks like. All right, we'll do one more. One more. Variable names must be relevant and descriptive. Is it a C language or a style rule? Yeah, I don't know how someone's like put it into a website and copied the text. So, pretty creative. Yeah, 100% it's a style rule. C doesn't care or know about what relevance is. And it's a good rule to have, so it's definitely not a rule. And let's see what this has done. Not a big change here because obviously everyone has got that right. So we're going to call it there. How do I end it again? Settings. End now. So congratulations to the Style Kings Noah. Hopefully that's a different Noah from Noah Mohamed. Epic Coda, congratulations. And then, who's this? Oh, this is a fancy animation. Oh, we do have a tie. Exactly the same score. That's sad that it's put you lower. I promise that's not me. Cool. Alright, let's take a 3-minute break. I'm gonna go just get some more water and make a quick coffee. And then we'll be back to talk about functions for the rest of the lecture. Okay, right on time, AR11. I am back. Okay, I thought I said 5 minutes. Anyway, all right, we're all back. We're all good to go. I'm really excited to talk about this topic. I'm hoping that we have a few aha moments here. So let's get straight into it. So we're talking about functions. You've probably heard the word functions. Maybe in 1511, maybe outside of 1511. Let's start talking about it so that we can start using them in our programs, because they're probably one of the most important building blocks or artifacts in procedural programming. So let's take a step back for a second, because I know there's been some sort of discussions and some cute confusions, and some of that has been a bit intentional actually on sort of my and our behalf. So far in 1511, right, we've talked about this idea of procedures in our C programs. So if we have a look at some code here, I've got this code called functions.c that I've just written up in the break. And we have, int main here, and we can call do something, okay? We can call that there. And we have been calling this thing a procedure. Why are we calling it a procedure? It's this thing called, in this case, I've just called it do something, which can store some instructions or contain some instructions that gets executed when we call that procedure. So do we have any questions just on this so far? What makes it a procedure is that it always returns nothing. So we all of our procedures have this void thing in front of it. And a lot of the ones we've spoken about so far, okay, everyone always gets me on the return 0. Yep. But that's not really key to what we're talking about, but thank you. But we have this ability, we could call printf, scanner, we could do whatever in here, we can make variables, but we have this ability to group some instructions in this thing that we can name. Okay, so any questions just on that? So Jerry has asked, how does C know which function is the main function? It has to be called just lowercase main. Julia has asked, can we do return 0 inside a procedure? No, procedures never return anything. That's what makes them a procedure, and that's what delineates them from the function, which is what we're going to be talking about shortly. So this is a procedure, Joe. This I'm just showing you as a recap. This is a procedure. Zach says, when we call a function, why don't we put void in the brackets? Yeah, we just don't. It's a good question. I don't know if you actually could. I don't know, actually. Someone can potentially answer. Blah, blah, blah. So I'll answer, Fake Olive, I'll answer your question in a moment when we talk about functions. Okay. Yes, and Jacob, we can assign variables in a procedure. Okay. All right, they don't return anything. Exactly right. So, whoops. That's what we've had so far. Also, we've used functions. So, and actually we've used procedures. So as an example, printf, when we call printf, let's say we call printf here, some stuff goes inside of it and we give it a semicolon. Whoops. I'm calling a function already defined in standard io.h. So this sort of comes with the C programming language. So we've used them too, and we've made some of our own. But what's actually going on here? What's the difference between procedures and functions? So, like procedures, a function is a way to break down our code into smaller functional bits, and each functional procedure performs some sort of operation and can have some input and output. And we can call our functions from anywhere in our code to perform its job and then to return to its spot. So again, we have this example here. This is a procedure. Why is it a procedure? Procedures always return void, so it doesn't return anything, but they do something. They, for example, print some instructions, and they may or may not receive some input into them. But this is what we've already had so far. So what is this? In this example, what makes this a function and what's the difference between a procedure? Well, a function now is just like a procedure, except that it returns some result. So it goes off, it does some computation, it calculates something, it finds something out, and it returns it. So this is a really simple example of good call. This is a really simple example of a function called add. This add function, if we break it down, it's no longer returning nothing. It's not returning void. It's actually, in this case now, returning an integer. Okay, it's returning a number. It has an identifier. We're calling it add in this case. That's exactly the same as what we've already been doing. And in this case, it contains two parameters. This is also a new concept we haven't discussed yet. So the function actually accepts some input and produces some output. How do we give back that output to the caller? We use this return keyword here. If we think about it, let's go back here. Our main, we've already been writing functions. Main is a function that returns an integer. It accepts nothing in this case, and we usually return 0 at the end. So when main is called, and main is a special case because it's not called by us in our program, it's called by the operating system. It goes off, it does some things, and then it returns some number. So this number has to be an integer. Why does this number have to be an integer? Because we are indicating here that it should be returning an integer. So let's actually write this add function. So, okay, I want to write a function called add. It's going to add two integers together and return an integer. So what should the return type be of this function? Can everyone tell me? I know we just saw it, but it's worth discussing. And actually, this is a good opportunity to code alongside me. So let's break this down. We want to add two integers together and return the sum. So a few of you are saying int sum. Well, we are returning the sum, but what's the type of that variable or the type of that value? It's definitely an integer. So it goes at the start of the function declaration. So it's replacing this void. We're no longer returning nothing. We're actually going to be returning something from our function. So we're going to say that we return an integer. What are we going to call our function? Well, we've spoken about style all day, so we need to say that, well, we're going to be returning, we're adding two numbers together. So we could call the function, for example, sum integers. We could even call it that. That would be okay. We could just call it sum. That would probably also be okay. We wouldn't want to call it my sum because my is a bit sort of unnecessary, but it's not a bad idea either. All right, that's the name of it. We put our brackets here. Now, if we're going to be adding two numbers together, I don't know what happened to my voice then. If we're going to be adding two numbers together, we need the two numbers that are going to be added together. Agreed? So the way we do this is we can basically list out the input into this function. So anytime we have some input or some data, we need to know the type of that data. What's the type of, we're saying we want to add two integers together. So I'm saying, okay, we need an integer and we'll just call it number 1. Then we use a comma and we can say another integer, number 2. And that is the declaration of the function. All right, so let's pause here for a second. Do we have any questions on what we've done so far? Joshua, you ask a good question. Do you define functions under main or before? So in general, main is at the bottom of the file and everything that you call should be on top of main. And if you call something from that function, that goes on top. However, we'll talk a bit more about some nuances here in a moment. Okay, Alexis and Noah's already answered this, but I wanted to discuss it. So the difference between these two things is that we can input something to functions, but we can't into a procedure. So that's not exactly true. We haven't done it so far, so your question is really astute. But you can absolutely have, int x, int y as input into a procedure. However, it will never return anything in the procedure. So this would be completely okay. Alrighty. So Leo is saying, I don't understand why we're putting number 1 and number 2 inside the brackets. So I would like to have I don't have it near me, my tablet, but you can think of functions and procedures, but we can think of functions as these computational boxes that do a calculation. And sometimes we need input into that calculation. So let's see, who asked this again? Okay, Leo. Right? So Leo, let's say I asked you to tell me the temperature on a particular day of the week. Do I need to tell you anything else for you to give me an answer? And anyone can answer this. It doesn't just have to be Leo. So if I'm asking, if you're a function called, temperature on day, what do you need to know in order to give me an answer? Exactly. You need to know. You need to know what day I'm asking. You need to know the day. That's exactly right. Time, location, you probably do need to know those things, but let's not worry about it. But if your job is to give me the temperature on a particular day of the week, you need to know what day I want you to tell me on. And so that would be an input into your function. The way we declare an input is by putting the variables or the arguments in the rounded braces. Now, someone asked, why can't we just do it here? So someone's asked why we can't do this. The reason we can't do this is these are just variables. These are just variables. They're not input, whereas these become input into the function. And maybe I think it'll become more clear once we actually call these functions. Okay. So if we have this function that we're calling sum integers, what are we actually going to do with this? We're going to add the two numbers together. So what we can do here is we can do a few things, but we can make a result. And then we can say that result is equal to number 1 plus number 2. Oops. Now, this result variable is storing the sum of the two input integers. Now, there's one thing missing from our function. How do we... I don't want to say the word return because then I'm sort of giving the answer away. But in the C programming language, how do I tell my function what I want to actually return? Yeah, so Nickels on the money. We need to say exactly what it is we want to return. So we can say, well, I'm going to return this result variable, the value in this result variable. Absolutely right, Alex, as well. Now, that's it. That is a fully formed function. I've got a few questions for all of you. And if you're watching this video later on, you can sort of answer in your head or something like that. So I've written this function. I've declared this function. Do I know what number 1 and number 2, what the values will be in the future? Do I know what the actual numbers are going to be? So Joe is saying no, Nicole is saying no. That's right. I don't know how it will be called. I don't know what the numbers are going to be. All I know is that this function can be called. If it's going to be called, it must have two integers passed in. I don't care what those numbers are. I don't care what those values are. All I care about is that I will add them together and return it. That's right. When the program's executed, that's when we can actually read what the values are. And for example, do calculations on them like this. That's exactly right. Let's see, some more questions. I want to pick apart everyone's understanding to make sure you're really sort of getting it. Do I care what the names of these parameters are? That's my doorbell, 1 second. I think that was just a delivery. Do I care what the names of these are? It's a really intense doorbell. Yeah, I know, yep. It gives me a panic attack every time it rings. It's not food, it's not food. Yeah, these are just like variables. They can be named anything. Sorry everyone for the fright. These can be named anything, but they represent the names of the variables that will store the input. Okay, so there's been some questions about return. Return is a special keyword in the C programming language, and it does something really useful. And its job is to define what this function's final result is going to return. So the lecture code for functions.c says you don't have access. You should have access. Let me maybe try again now. You should. I thought I already did that there, but maybe I didn't. So how does return work? What return does is it comes across return. You look what's on the right-hand side of return. You evaluate that expression and it gets returned to the caller. And we're going to talk more about what the caller means in a moment. So Dwayne, nothing here gets printed, right? It's just, if there's no printf statement, nothing's being printed. We define a variable, we assign something to the variable, and we return it. All right. So in our main function, let's actually call this new sum integers function. How do we call a function or procedure that we've declared? So if I want to call this function, what do I type? Yep. So, we want to call what we named our function. So sum integers. Now, we have some brackets here. If we look at our function declaration, we have to give it 2 integers. Where do you think I give it those 2 integers? And I know I've put my cursor sort of, I'm sort of hinting, but yeah, and a lot of you are typing this out in the chat, in the chat. The input now gets passed inside of the braces. So let's, for example, just say 3, and 2 and 3, for example. All right, and let's put a semicolon here, and we'll save that. Okay, cool. So we declared a function. We've said it needs 2 integers as input. It returns that result. That all looks good. We've called this function, and we've given it 2 integers as input, the integer 2 and the integer 3. And actually, this is all going to fully work. But let's actually run this. I'm going to delete this here. We'll leave that like that. DCC functions.c to out. I'm going to call this functions, and it should compile with no issues. Okay, very cool. I clear this, I run functions, and what are we going to see? Nothing. Nothing's getting printed to the terminal. Is this what we expect? Okay, and Nikhil is, once again, bang on the money here. Yeah, I'm not printing anything. I'm not doing anything with the sum. Nothing's happening. Is it working? Is it not working? Okay. But Nichols says, but what if we want to use this result variable in the main function as part of the input to another function, for example? How would we do that? But I guess before we answer this question, it leads on to the next point here, which is we called some integers. We gave it the input of 2 and the input of 3. But then how do we actually do anything with this result that it calculates? We're not using it. How do we use the result? Does anyone know? The answer is that when we call a function, it goes off, runs the function, calculates this result, returns the result. And this whole function now becomes, it gets evaluated to the result. So you can imagine that we call the function. It gets evaluated, in this case, to 5, because it adds 2, right? And then 3 together and returns it. And then we need to do something with it. How do we do something with it? It's really simple. It's just like any evaluation, any expression. So let's say we have our int sum. I can really easily just say, well, our new sum is equal to the result of calling some integers. And some of you have already put this into the chat. That's fantastic. So we go off, we call some integers. Some integers does something. It adds 2 and 3 together in this case. And it assigns the value of the result that gets returned, whatever it is that gets returned, goes into sum. Then, let's say if I want to printf %d, lowercase d, \n, I think that's all fine. I print out that sum, and then I can just compile this. and we get out this number 5. How exciting. I'll put this like this. And this is our first practical example of declaring our own functions in the C programming language. So Elizabeth has asked a good question, which Noah's answered, but main's a bit of a special case, and we can talk about it more in some more detail another time. Okay. All right. How's everyone sitting with this? So, okay, we're getting some questions in, and they're all really good questions, but they're not really around clarification. So what I want to focus on first is, does anyone have any questions or misunderstandings, or doesn't quite fully understand what we have here so far? Could we maybe do a poll? Actually, I can quickly do the poll. I'll do the poll. How is this all sitting so far? Okay. I love how many really good questions are coming in. We're going to answer all of them, I promise. I just want to focus right now on, let's not focus right now on sort of extensions and other ways we can use these functions. I just want to focus on if there's anything that people aren't quite getting with what we have so far. You don't have to get 100% of everything, but just the core basics of what we've got so far. Anubhav says I'm wondering what would happen if I call some function in the sum function itself. Can we do that? Technically, you can do that. This is something called recursion. We're not talking about it. Definitely not today, but it is actually possible. So, okay, 75% of us think we get it. That's a pretty good number. If you're in the percentage of people that aren't quite getting it, that's completely okay. It's a brand new topic. It really helps if you follow along yourself, and you can ask any questions you've got here. Okay. All right. So let's try and talk about some of these extension questions now. So a person says, I don't quite understand where we'll use this. Functions are one of the most useful things in programming, and I promise in some more examples, it's going to become clear. And I'll do some more examples even today. So I promise it will be clear why we want these. All right, the chat's popping off. Okay, this is a good question. Cho Sun has asked a good question. Can we print f some integers instead of using sum is equal to some integers? And the answer is yes. So there's a few things I'm doing here that aren't strictly necessary. And we can talk about that because it might help you understand what it is that we're doing. So if you look at when we called some integers, what I did was I signed the result to sum and then I printed out sum. But we can also do printf %d \n, comma, and instead of using this sum variable, we can just print, we can actually just print the result of calling some integers. Now, you need to put the brackets in and you need to put the input, the arguments, but we could change these two arguments. So we could do 5 and 1, for example. So what we would expect to see here is the number 5 printed and then the number 6 printed. And that's exactly what we see. So again, if we think about what's happening here, we're saying we want to printf an integer. Okay, that's the format string. This is what we're printing. We come and call the function. It adds 5 and 1 together. stores it in the result, which is 6 in this case. We return 6. So this, you can imagine, sort of gets replaced with 6, and then we just print out 6. So Elizabeth is saying, why didn't you define number 1 and number 2 as integers? And actually the answer is that, oh, okay, you mean down here? Or do you mean up here? I guess is the question. So, yeah, the point is that when we declare the parameters or the variables, we have the integer here. When we're just calling it, we don't need to, we just have the integer value. Yeah, in main, right. These are just values. They're just literal values, so they don't have a type because it's not actually a variable. It's just an integer. Okay. Leo Bob says, is there a way to scan number 1 and number 2 without assigning it in the code itself? Absolutely. I could scan F in, number 1 and number 2 here, and then pass those in to some integers. So it doesn't really matter what I pass in here, as long as they get evaluated to an integer. So if we think about this, like what I can do here, this is a bit of a weird example, but I could do 3 plus 3 here, right? This would get evaluated to 6. We would call some integers. It would be 6 plus 2. That's 8. And we would see, 8 printed. So it doesn't really matter what it is that we pass in as long as it evaluates to an integer. So this could be a variable that's the result of a scanf. All right, why don't we sort of move on a little bit, but these are all really good questions. I want to talk about really briefly one more time and sort of provide a clarification on what we've been doing here. So again, what's the difference between a procedure and a function? Again, procedures can have input, so it's not that. It's just that procedures always return nothing and functions always return something. So procedures always have a void at the front of it and they never have a return statement. Functions always have a return statement. So is that delineation between procedures and functions clear? Now, here's the misconception that sort of gets a lot of people, I think, and I've sort of intentionally set this up because I think it's really important. So what I'm about to say is quite important. I think it's important. In C, right, technically, I guess, these are both functions. They're doing the same thing in the language. A procedure is a function in C. It's not a new artifact. It's not a separate artifact. Some people will call procedures in C a void function, right? It's a function that returns nothing. This is a function that returns an integer. So you can sort of see that they're the same thing, right? However, the difference comes from the concept or what we are aiming to do with it. So, procedures should do something, which means they should have a side effect. So they could print something to the terminal. They could go and, create a file or do something like that. Whereas in theory, sort of functions, they shouldn't actually do something. They should just calculate and return something. So functions should always calculate and return something, but they shouldn't, for example, print to the terminal, because that would be a side effect. You can do that, and you might actually do that, especially if you're debugging. But what I just want to be, sort of communicate here is that we have these two ways we can use functions. We can get them to do something, or we can get them to calculate and return something. And that's it. But they're both the same thing. So Ariane says, if the function is to return a print statement with the value, with a character, what would you initially define the function with? You might have to re-ask that question. Maybe Noah or Tammy can try and answer your question there. So Lockie says, are functions almost exclusive to math? So no, but your thinking is 100% right there. What I would say is functions are exclusive to calculations. It might not be math. It could read a value from a file. It could do so. It doesn't have to be just mathematical calculations, but yes, they are calculating something and returning it, and that's it. And common, that might just be math. Anubhav says, but aren't procedures the way we have used them returning strings of characters? No, they're not returning anything. They're doing something. It might be printing to the terminal. But they're not returning anything to the caller. There's no return statement. Alvin says, would you use a function or a procedure for an input? You might have to clarify again what you mean as well. What do you mean by input? Yes, Polka, we can have we don't just have to return integers, we can return any type, and we're going to talk more about that in a second. Okay, yeah, okay, I think by choosing int here, I've confused people because we've only ever seen integers. So let's do that. I'm going to save this. I'm actually going to go gedit functions 2.c. Open this one. Okay. All right, I'm going to do this. Then I need to go here. Then I need to make the file public. All right. All right. Let's do another sort of real world example of some useful functions. Okay. So I want a function. Let me just get something up. Okay. Yep, light cursor, you're 100% correct. If the function's returning nothing or void, then it's a procedure. Yep, okay, cool. All right, I'm just trying to think of a good example here of something. Give me a quick second. Okay, I've got a good one. All right. So Joe says, I get it a bit now suddenly. That's fantastic. That's the aha moments we want. All right. So far, the functions we've used have only returned integers, and we had sum, which is a really simple function, and you wouldn't really necessarily even need it because you can just add, x plus y. You don't really need a function for it. So let's talk about why, some other examples. So what if we want, let's say we want a function to print the area of a circle. Right, so that's my problem statement. And again, we have 15 minutes left in the lecture. It'd be really good if we all followed along, typed along on your computers as well. So we want a function to to return the area of a circle. All right, so what do we think this function needs to return? What type does it need to return? So Alvin said you ask a great question. In that example, you would want to use a function because you would want to return what the user typed in. And we can do that in this function. Okay, all of you are saying int or a float or a double. Exactly. Because it's an area, it's probably going to be a double. So we just say, I want to return a double. What are we going to name it? Well, we're calculating the area of a circle. I'm going to call it area of circle. I'm going to be nice and expressive. What input do we need to have in order to calculate the area of a circle? What do we need to know to calculate the area of a circle? Quick math. Yeah, right, exactly. We need to know the radius. And if we need to have the radius as an input, it needs to go as a parameter in the braces. And what type is that going to be? We need to know the type. Again, I'm going to say it's probably a double. Exactly, Anubis has got it, Nicola's got it, exactly. That's it, all right. I want to calculate the area of the circle. So what's the function, what's the mathematical expression used to calculate the area of the circle? Well, area is pi times r to, r squared. So we need to implement this in our program. How do we do this? Well, pretty simply. We take pi. Now for this, we can use a constant. Pi is 3.142. That's right, isn't it? That's enough for us. So we have pi times the radius. And now the radius needs to be, Anubis, good work, you got that. So the radius needs to be squared. How do we do that? Well, we can take this in brackets and say radius times the radius. That is just radius squared. This expression should calculate the area. What do we need to do now? Yeah, arc, you've got it. We need to return that. We've calculated it, we need to return it. Previously, what I did was I made a variable, I assigned this to a variable and returned the variable, but I can just return this. I don't need to assign it to a result value and return it. I can just, that shouldn't be C, I'm so sorry. I think I hit copy and I'm getting it now. I hit copy and then the C, I pressed the wrong key, and then it put it in. And that should be, yep. Sorry about that. My bad. It was a typo. Okay, cool. But the cool thing here is I don't need to assign this to a variable. I can just return this straight away. Okay, so that's our function. Our function is fully formed and it's returning the result. Now, if I want to call this function, I use the name of the function and I give it the input. I could just give it 5.1. Let's just do that for now. And what if I want to print this to the terminal? Okay, well, I can just print f from here. What's the formatter character for a double? Who can remember? While you think about that, I'm going to set up the rest of this. I'm going to just call the result of the function directly, put my brackets there. Yep, Matthew got it first. It's LF, % long float. long float is a double. And that's actually it to start. Let's compile this. This is called functions_2. That worked, I think. And then I can call functions. I just compiled it to the name functions itself. And you can see that we get 81.72 printed out. And if just to prove it, 5.1 as a radius is 81.71. 723, that gets rounded to 81.71. And so we've defined this function that's doing what we want. Now, let's say we want the user to input this number. I could have, make a variable here, scanf it, print out some instructions, but that might clutter up my name. What I can actually do as well is make another function that returns a double called read radius from user. It's going to accept no parameters because it doesn't need to. And what I'm going to do here, I'm going to do some printf. I'm going to go a little bit faster here, so I apologize if you're following along because we've only got about 10 minutes left and there's something else I want to talk about. But I can print out, for example, please enter the radius to calculate the area. I'm going to do like this. And then, so it's going to print out some instructions. Then I'm going to make a variable called radius. And I'm going to go scanf. Radius. We're going to scan it into the radius. How do I scanf into a long float? I do a %lf. I need to give this an ampersand to show that it's a pointer. That's right, isn't it? I think that's right. And then I'm actually going to return this radius. So this function's job is to print some instructions and then read in and return this radius. Okay, so I think that's okay. Should be. Then if I want, so instead of using 5.1, I can actually, I could call I could just do this. I could do this. In fact, why don't I do this? Yeah, I forgot the return 0. Once again, that's the bane of my existence. So this is going to first read the radius from the user, get it read in, return it, and then pass that into the area of the circle and then print that. That's pretty cool. So let's run this. That compiled just okay. I run that. Please enter the radius to calculate the area. I'm going to say the radius is now 10. I hit enter. It takes that 10, passes it into area of the circle, returns the new calculation, and then prints that out. And that's pretty cool. In fact, let me just put that there. So Noah says, how do we construct functions outside of main? These are all constructed outside of main, right? They exist before main. That's cooler than calculator, yeah. Now, the cool thing about functions is that they're reusable. So I can print this, and then I could simply print, 10.1. I can just keep using it. And I only ever had to define and think about the mathematics of it one time. And that's the value of functions. We can define these reusable functions that we can reuse over and over. Okay. That was our demo. We spoke about this. That's fine. Okay, function prototypes. This is what I want to end the function on. So Alexis, yeah, you can absolutely reuse procedures. As a quick example of that, let's say I want to void print instructions. Void here. Right, this can go here. This can go here. And then I could call print instructions. And then I could also call print instructions. You know, I don't really want to do this, but I could call it here. And I could reuse this procedure that we've written. You can't call main inside of the program, Betsy. It's an interesting question, actually. Yep. Okay, all right. We have an interesting thing that actually happens here with these functions, right? If you look at all these functions that I've been declaring them above main, like physically in the file. Main's at the bottom, then we have read radius, then we have the area, then we have the print instructions, right? But let's say I put in, and maybe I'm actually going to undo that last change just to keep it really simple. Let's say I define this area of circle function below main. What's going to happen here? Is this going to work? We actually get a bunch of errors. We actually get a lot of errors here. And basically the error, if we find that, you know, we'd have to read through these errors and read sort of carefully, but you can sort of see, here we go. This is probably the nicest explanation. You're calling a function named area of circle on line 17. There it is here. But DCC, the compiler, does not recognize it as a function. But it is a function. It's down here. So what's going wrong here? What did we change that caused this error? We moved it. So funny man says we're returning 0 before the function is stated. That's not the problem. The problem, I mean, you're sort of right and you're sort of not quite right. Yep, the compiler reads from the top to the bottom, the compiler reads from the top to, exactly right. What's actually happening here is that the compiler's coming along and it goes, okay, I've got this function called read radius void. I've got this function, I've got the main function. Yep, I need that. And then it's going, well, but main calls area of circle, but area of circle, I haven't seen it yet. I haven't seen it yet at this point. Therefore, I'm going to throw an error. I haven't seen it. Because it's defined underneath main. Because it's coming through from the top to the bottom, making sure that everything's in its right place. And because it's below main, or below the caller, happening here and here, it's giving us an error. So we need to talk about two ways in which we can fix this problem. There is two ways we can fix a problem. The first way we can fix it is by simply putting it above, and that's what we did at the beginning. If I run this, I get no output. I get no errors. That works. But there's actually there's actually another way we can fix it, and the solution is to use something called function prototypes. So what we can actually do is we can tell the compiler, hey, you're going to try and compile my program and you're going to get annoyed at me because I haven't declared area of circle before I called it. Right? So what we can actually say is, hey, Mr. Compiler or Mrs. Compiler, I actually... Trust me, I will have this function. I will define it. I promise. And the way we can do that is by simply just copying what we call the function signature. Actually, I'm missing the double at the start. And simply listing it at the top of the file. Just like this. So now if you think about the compiler coming through, it's like, okay, we want to include standard IO. We want to define this pi. Ooh. The program is telling me I don't have the implementation of it, right? I don't have the body, but the program is telling me I will have this function called area of circle that accepts a double radius and returns a double. I haven't said how to implement it yet, but I'm just saying the prototype of it. And the prototype always includes the return type, the name, and the types of parameters. So it must include this double. It must include the correct name. Like it has to match, line for line, as character for character, what we define down in our function over here. And if we do this, so we're telling the compiler, hey, please trust me, don't worry about it. I will have this function. When we compile it, we actually get no errors and it works again as we would expect. Right? So those are two ways in which we can satiate the compiler into understanding that we will forward, have this function available in the file. It's okay. Note the semicolon at the end of each statement. So we need to make sure that we define it. And what we sort of do just to be, safe is we can really simply just copy all of the functions that we want to declare. We don't do it for main, and list them so that the order of them doesn't matter. And that's how we can define the prototypes of our functions in C. Whew, all right. Okay, that's actually fantastic timing once again. A few of you are asking, why do this? Why not just orient the functions in order? The answer is it's a little bit complicated. And it's probably a discussion we can have in the future when we talk about multi-file programs and things like this. If we read, I'd be curious to read the... If we look at the style guide, whoops, let me go to the right term. If I search prototype, here we go. Function prototypes must be blah, blah, blah. It doesn't really give us a good reason for why we have it in the style guide, actually, to be honest. I think one of the reasons some people do this is just to, just to have more flexibility, so you don't have to worry. Sometimes in longer files, so to be completely honest, like I didn't write this exact rule in the style guide, right? What I think the reason is when we have longer files, longer programs, we might call a function from another place. And what that means is because we're changing the order that we're calling the functions, we will get the out of order errors coming up, right? And it's just annoying to have to reorient our function declarations as we're developing. Does that make sense? So to avoid it as an issue, if we declare the prototypes, I can say, oh, I actually want to call area of circle, from here. I change the order that I want to call it, and it won't be an issue because they're all declared as prototypes. So it just gives us a bit more flexibility, especially in longer programs. That's how I interpret the rule. You could also make the argument that you should just orient it with main at the bottom. That's probably valid. And things get more clear / complicated when we have multi-file programs. But in the simple answer is in 1511, in our style guide, we want all the function prototypes declared at the top of the file, so that the compiler, like Julia, is identified, so that the compiler knows, we're telling the compiler, hey, these are the functions that I'm going to be using in my program, and then we don't have to worry about the order too much. Yeah, and it might allow functions to be scanned at the top of the file so you know what's available. Sure. Exactly. Okay. Alrighty. Well, we're 5 past. We went through a lot of stuff today. Let me go back to my slides. As always, if you don't 100% understand everything that we've spoken about today, that is okay. You've got the tutorial and labs coming up on these topics that will help get you doing practical stuff on them. They'll start appearing in the assignments, and you can always rewatch the lecture content. We'll timestamp it so you can watch the bits that you just want to rewatch. So please, I always appreciate the feedback. I do read every single one, and I make small changes here and there where I can. Thank you all. Enjoy the rest of your day. The sun's come out. Hopefully it's warming up. Thank you, everyone. Great work today. Thank you to Noah and Tammy for the moderation in the chat. It looks like we got rid of the bots. That's a win. So that was something that was coming up in the in the feedback that we seem to have fixed. So thank you all. Have a lovely day. I will see you tomorrow at 3 o'clock to continue on with the lecture content. See ya. Go Socceroos, hey?